My name is Malachi Dyer, and this is my presentation on biomechanics. Biomechanics is the analysis of movement within sport. Dividing the word into its roots, bio refers to the physicality of the subject, whereas the word mechanics demonstrates the movement analysis that is produced due to forces applied. Within biomechanics, kinematics is the understanding of the motion of objects. It covers displacement, distance, velocity, speed, acceleration, and time within its concept. During the next few slides, the types of motion within kinematics will be explained in more detail. Firstly, I will be covering the types of motion. Motion is a huge aspect within sport that analyzes the direction and movement pattern of the athlete. There are three types of motion that I'll get into more detail about in my next few slides. These include linear, which can be subdivided into curvilinear and rectilinear, leaving the other two types of motion being angular and general motion. All movements will fit into one of these motion categories. Motion is governed by three laws, the first of which being the law of inertia. This law states that the object will remain at rest or in uniform motion unless an external force acts on it. This means that if any sort of friction or resistance is applied to the object, it may not remain in uniform motion. The second law plays a role within force and acceleration, showing that F equals ma, or force equals mass times acceleration. Many athletes will use this for their advantage. An example of this could be through a basketball player who will use acceleration or force by adapting their mass to produce quicker changes of direction or to jump higher. Lastly, the third law demonstrates action and reaction. This shows that when athletes interact with the environment, force exerted will equal, causing the opposite reaction. This is how swimmers propel off the pool wall or how footballers strike the ball. The first type of motion I will cover is linear motion. This can be defined as motion in a straight or curved line where all parts of the body move the same distance at the same time. An example of this could be seen through a 100-meter race. The torso is performing linear motion as the athlete is driving along a straight line. However, linear motion can be divided into two subsections, the first of which being rectilinear. This is movement of the body along a straight line, whereas its counterpart, curvilinear motion, would be movement of the body round a curved line. As you can see in the image on the top right, the motion is rectilinear, as it is a straight movement from point A to point B. On the other hand, the second image would be defined as curvilinear, as the movement is from point A to point B is curved. An example of when rectilinear motion is used within sport could be through a cricket bowl, as the bowler is trying to get as much driven power down the pitch as possible. An example of when curvilinear motion is used within sport could be in a 200-meter sprint, where the runner must run round the bend, performing a curvilinear motion. Moving on to the next type of motion, angular motion can be defined as movement round an axis. This includes rotating bodies, levers, stability, a movement of force, the axis of rotation, a movement of inertia, and angular momentum. Angular motion is used a lot in long-distance sports. An example of this could be during a cycle where the ankle is rotating round an axis to perform movement. Additionally, it is also doing this at the hip and knee. Lastly, general motion is a combination of angular and linear motion. This is usually performed in motions that have high energy expenditure. An example of this could be seen through a runner, as the trunk is performing linear motion and the hip and ankle and knee is performing angular motion. Therefore, the combination of these two things proves it to be general motion movement. Moving on to measurements, mass can be defined as the quantity of matter within a given object. Mass is dependent on gravitational field strength, which is basically how strong the pull of gravity is within a given area. On Earth, our gravitational field strength is 9.8 newtons per kilogram. Mass will be used when calculating forces and weight. A sporting example then when mass could be used is through a high jumper. if the athlete's mass, moving on to measurements, mass can be defined as the quantity of matter within a given object. Mass is dependent on gravitational field strength, which is basically how strong the pull of gravity is within a given area. On Earth, our gravitational field strength is 9.8 newtons per kilogram. Mass will be used when calculating forces and weight. A sporting example of when mass is used could be through a high jumper. If the athlete's mass is 60 kilograms and the gravitational field strength is 9.8 newtons per kilogram, then the product of those two values will give a weight of the athlete, 588 newtons. The more mass that the high jumper has will increase the weight of the athlete, which could affect their overall performance massively. Next up is weight. This is different to mass, as weight is the force that acts on mass due to gravity. Weight is used to find mass and the gravitational field strength of an area, although this is less likely as Earth has the same gravitational field. Weight can be found by finding the product of mass and gravitational field strength of an area. An example of this in sport could be during a powerlifting competition. Where next up is weight. This is different to mass, as weight is the force that acts on mass due to gravity. Weight is used to find mass and gravitational field strength of an area, although this is less likely as Earth has the same gravitational field all around. Weight can be found by finding the product of mass and the gravitational field strength of an area. An example of this could be during a powerlifting competition, where the athlete's weight is a very significant figure deciding the outcome of their performance. And I'm going to talk to you about vector quantities. Vector quantities use both direction and magnitude to give a number. They are used in many places and are very helpful when deciding more accurate representations within sport. Vector quantities are used a lot when there is a change of location or when distance is increased. An example of this could be through velocity. Velocity is a vector quantity and is found through dividing displacement by time. The supporting example is a swimmer swimming 50 meters in a 50-meter lane in 30 seconds. Looking at the calculation of velocity, we know that the displacement is 50 meters. We have to divide that by the time of 30 seconds to give the result of 1.67. As it is a vector quantity, direction must also be shown in the answer. The directions are north, south, east, west, positive, and negative. In this case, the swimmer is traveling positively to give the answer of positive 1.67 meters per second. Secondly, there is a scalar quantity. This is a value that has only magnitude without direction. Scalar quantity examples include mass, length, volume, and time, as these are whole numbers without the sense of direction. These are usually simpler to understand. A sporting example of scalar quantity could be seen through distance. To calculate distance, you must find the product of average speed and time. If the time it took traveling at an average speed of 5 meters per second was 400 seconds, the product of these two numbers will make the distance of 2 kilometers. This is very helpful when looking at long distance events, as it will not usually be in a straight line, which means it could be much harder to find a vector quantity. Thank you for listening.